Okay, so here's an example of that. Now, sometimes you can just look at a graph and see the answer because it passes right through the grid lines where you can see it's an integer value. But sometimes it's a fraction of some sort. Okay? So on something like this, it's giving you an absolute value equation. So right here, this red graph is the graph of this equation right here. And it's asking you to determine the values of x for which the y values are positive. And what I'm starting to introduce with this is I want you to be able to see just on the graph, where does this graph have positive y values? Well, the positive y values are the places where the graph falls in quadrant 1 or 2, right? Quadrant 1 or 2 has positive y values. So you're looking somewhere in between these. So you see that your answer's somewhere a little bit beyond 4.5, and it goes all the way to just under 5.5. And so your answer is going to be somewhere in that range. So what you can do here is you need to be able to convert this equation into an inequality. And the way that you would do that is take the equation, or the equation as you see it. But instead of setting it equal to y, what we want to do is we want to find out where this is positive. So positive values begin where? At what number? Even less than that? 0, right? So 0, at 0, they're neither positive nor negative. So we want values that are what compared to 0? Greater than, less than, greater than or equal to, or less than or equal to? So they have to be greater than. So what we're doing is we're taking this equation, creating our own inequality from it, and then we solve the resulting inequality. Okay, so our steps were, to solve this, we isolate our absolute value, so we subtract 2 from both sides. Again, subtracting 2 doesn't change the inequality symbol, but when we divide by a negative, now it does. We flip this, negative over negative cancels, we get 1/3. Okay, and so when we solve this, a less than problem, absolute value inequality, is going to be sandwiched between 2 things. So we take our expression, we sandwich it between the 1/3 and the opposite of that, and we solve the resulting equation. So we're going to add 5 to both sides. Adding 5 is like adding how many thirds? So again, I'll always think in terms of whatever the fraction involved in the problem. So if I add 15/3 to both sides, I get here 1/3 plus 15/3. And here I get a negative 1 plus 15. So there is my answer. I have, when I write my answer in interval notation, a lower limit of 14/3, an upper limit of 16/3. Neither one is included, so it's parentheses. Now, does that seem consistent with these x values right here? Is 14/3 beyond 4.5? Yeah. Is 16/3 a little bit beyond 5, but less than 5.5? Yeah. So it's consistent with what you were expecting. Okay, now, the other way that this problem this problem will randomly generate the equations, but it also will randomly generate this. So it might ask you to find where those are negative. Now, when you look at the graph, the point where those are negative is going to be looking at this same graph, right? It's from this part here and this part here. So what you can see from the graph itself, it's going to be the same critical points, right? 14/3 and 16/3. The only difference is now it's going to be from here and here. So if we had a negative one, then the interval would be negative infinity, all the way up to, but not including 14/3. And then it would also go from 16/3 all the way to positive infinity, union of sets in between. So if the question had randomly generated looking for negatives, then you know you're going to have the 2 different intervals. Okay. So again, be aware of that. Depending on what your question is asking you, you should anticipate you're going to have a bounded interval if it's a less than, or I'm sorry, if it's a positive here. Now, in this particular case, with the way the graph is set up, right, if the graph was set like this, Okay? If it was a positive absolute value equation, then if it was asking for positives, would you have a bounded interval or the unbounded intervals? If it was asking for positive here on this graph, it'd be two unbounded intervals, right? It would be negative infinity up to this point, right around -6, and it'd be around -3.5 to infinity. Okay, so again, be aware of that. This would be looking for positives, and then here it would be from those numbers to each other if it was looking at negative. Again, it depends on where the graph is located, but trust what you see in the graph. Where is it positive? Where is it negative? That's what those inequalities correspond to, the actual graphs of those.